Hello, welcome to this video on integration by trigonometric substitution. Okay, so here we'll use a basic definition from trigonometry. Okay, so if you could remember, there is this definition that sine squared of theta plus cos squared of theta is equal to 1. Okay, now with this, if I try to name this equation 1 and divide equation by 1 by, so equation 1 divided by sine squared theta, then the next equation that will generate is sine squared theta over sine squared theta will be 1 plus cos squared theta, okay, over sine squared theta, and that will give us 1 over sine squared theta. Okay, so this is the same as 1 plus cos theta over sine theta is cot. Okay, and since they are both squared from indices, it will be cos theta over sine theta all squared, so we'll get something like cot squared theta, and this is equal to cosec squared theta. Okay, so this is the second equation. Okay, let me change it. All right, this is the second equation that we will generate. Okay, now if I divide equation 1, the same equation, by cos theta or cos squared theta, I'll get something like sine squared theta over cos squared theta, and that will be sine theta over cos theta all squared, so I'll get something like tan squared theta. Okay, so tan squared theta plus cos squared theta over sine squared theta is 1, and this is equal to 1 over cos squared theta, which is sec squared theta. Okay, so note this is the first one you should have in mind, this is the second, and this is the third, but mostly we use this one, the first one, and the last one. Okay, so remember all these things. Okay, now let's clean everything and write the two that you normally use them. Okay, so these two equations are what you are going to use in trigonometric substitution. Okay, so if you have the integral, okay, I'm writing each and every one of them that you are supposed to use some substitution. Okay, if you have the integral of, let's say, either the square root 1 over it or wherever you find it, if it is in the denominator, something like 1 over some s squared, okay, plus or minus a squared. Okay, now with this, let's consider the first case where it is minus, or it can be something like integral of 1 over a squared minus s squared rather. Okay, this case can also happen, or let's say something, let me call here b. Okay, I don't want to call it 1, let me call it b. Now if that is the case, then you're supposed to use either one of these. Okay, look at here, from the first equation, if I make sine squared theta the subject, is equal to 1 minus cos squared theta. Okay, so if you are to compare this, okay, to these two scenarios here, alright, if you have to compare this to this one and this one, then the a is a constant in this a squared. Okay, 1 squared, 1 is the same as 1 squared, it's also a constant, and negative S squared is the variable, S is the variable, and the variable is here. Okay, so the moment you have something like a squared minus, I'm coming, okay, something like this. If you have a squared minus s squared, either being the denominator of a fractional integral like this one that we are coming to do, or it is inside the square root. Okay, so the question can be like integral of square root of, let's say, a squared minus s squared, or square root of s squared plus or minus a squared. Okay, it can happen like that. Anyhow they come, any form that they pick, okay, being it square root or denominator, you're going to take any one of these. Okay, all right. So now, if that is the case, then this is how you go about it to set x to be equal to cos theta, so that I'll get something like cos square theta in it. I'll make sure that I get, like, from here, I'm talking about this side. Okay, let me clean some parts for you to know it well. Alright, so with this side, okay, for you to see it clearly, then it should be of the form 1 minus something. Okay, so you pick the denominator alone, only the denominator, a squared minus s squared. Okay, now if I want to factor a squared out, I'll get something like a squared out, then 1 minus s squared over a squared. I hope you can see that. Do you know why we are doing that? Let me write it well. So we said it's s squared over a squared. Okay, do you know why? Because if I multiply a squared through this, I'll get back this. I hope you get it. Now from indices, this is the same as a squared, okay, out 1 minus then x over a, okay, all squared. I hope you get it. So getting something like a squared is out now. Okay, now we'll get something like 1 minus x over a, okay, x over a all squared, something like this. So now you can see that this is mimicking this one. Okay, so if we set our x over a to be equal to then cos theta, then it means that our s over a square, okay, this side will actually give us what, cos squared theta, and now we'll get something like 1 minus cos squared theta, which is equal to this, so that we come and put it back in what we want to do. So if that is the case, then we'll be able to integrate it easier, because we get something like 1 over, let's say if we are integrating this, we get something like b over sine squared theta. Okay, on b over that, and then by then we'll have to change the ds to the theta, like, you know, we did in the substitution rule. Okay, so this is like you are doing some substitution, but then you are not just assigning any variable to it, you are looking at it, what trigonometric identity is it mimicking. Okay, all right, so let's consider the other cases as well before we start working, because I don't want to start working whilst you don't understand. Okay, so now the part where the denominator is like s squared plus or minus a squared. Okay, so with that one you use this side. Okay, now let's look at s squared plus a squared. This is the same as something like a squared plus s squared. Okay, nothing has changed. Since this is true, we'll compare this to this. Okay, that means I have to get something like 1 plus something squared. Okay, so I just go and, like we did for the course on, you factor your a squared out. Okay, and you get 1 here plus x over a all squared. I'm just writing this straight away because you get s squared over a squared, and that will be like this from indices. Now if I compare this and the second trigonometric identity, that is the 1 plus tan squared theta equals sec squared theta, you can see that the 1 equals 1, and now we'll have to set our x over a to be equal to what? Tan theta, so that if I square s over a, that is s over a squared, will give us tan squared theta. Then in that doing, 1 plus tan squared theta will give us sec squared theta. Okay, but then mind you, you have to change everything back into x, because doing this we'll get our answer in theta. Okay, what if it's like this, s squared minus a squared rather? So now you go back to your our second trigonometric identity, that is, if I make tan squared theta the subject, I'll get something like this, sec squared theta minus 1. Okay, then it means from here I have to make sure that I factor a squared out again. So if I factor a squared out, I'll get s over a all squared minus 1. Okay, from this side. Then from there I can pick it from there and do the same thing, that x over a should rather be equal to what? Sec theta, because it is mimicking this side. Okay, and it has to look like it, so that x over a squared, which is sec squared theta minus 1, will give us our tan squared theta. Okay, so let's pick a practical example and go through it. Okay, alright, so this is how it goes. Now I pick my denominator, which I can't do anything to it. Okay, and I say that it should mimic this one. Now there's no a, or there's no big thing here for me to factor out. Okay, it's just s squared plus 1, which is the same as tan squared theta plus 1. Okay, yes, this part is the same as this. Okay, plus 1 equals s squared theta. Okay, so with this I can say that I let my x be equal to tan theta. Okay, I mean the theta should be equal to, and I differentiate tan theta, I get sec squared theta. Okay, I've done a video on this, so if you don't understand it, you can go to check out my video and then you will understand. Okay, the x is equal to, making the x the subject, I get sec squared theta d theta. Okay, now if that is the case, if I put x is equal to tan theta, so if I put x back in the original question, that is the denominator here, this side, I'll get integral of 1 over, then my x is tan theta now, so s squared will be tan squared theta plus 1. Okay, then times the x is what? Sec squared theta d theta. Okay, I hope you get it. So let me clean this part. So this is what we got in for the x and this. So this whole integral has been transformed to the theta. Okay, now from this trig identity, tan squared theta plus 1 is what? Sec squared theta. Let me write it all for you. Okay, it's equal to sec squared theta. Alright, so if that is the case, then there is a d theta, so this whole integral becomes integral of 1 over tan squared theta plus 1 is sec squared theta, then times sec squared theta d theta, because the sec squared theta d theta is from here, the dx. Okay, now this sec squared theta can cancel this, and so everything becomes integral of 1 d theta. Okay, so if you can see, this is a strange integral for us to do, but it has reduced to what? A very simple one, integral of 1 d theta. And now in our first integral video, we said the integral of a constant with respect to some variable is just a constant times a variable. Okay, so this integral will be what? Theta plus c. Okay, so just constant 1 times the variable, which is theta. So this whole integral is equal to that, but we are not done. Okay, let's see why we are not done. Okay, So after putting everything in, this is what we had integral of 1 d theta, and integral of 1 d theta is just theta times 1 plus c. Okay, so theta plus c. Now we are saying that x equals theta tan theta. Okay, from this side, let me pick from this side. Okay, let me come and write it well for you to see. Now we are saying x equals tan theta. It means that, yeah, tan theta is equal to x. Okay, so if I want to find my theta in terms of x, then theta will be equal to what? Tan inverse of x. Okay, alright, so this whole integral in terms of x, that is this side, is now equal to tan inverse of x plus c. This is true because you are saying that integral is just finding the function that when you, which one you differentiate, you get this. Okay, so if I differentiate this side, I'll get this one. Okay, the one in the integral sign. And it's true, but whenever you integrate tan inverse of x, you get 1 over x squared plus 1. Okay, so that is it for doing trigonometric integrals, trigonometric substitution, sorry. But now let's go and solve this question. I have a special question for you. It's a combination of the substitution rule and completing of squares and trigonometric substitution as well. Okay, so let's stay tuned and let's do it. Okay, alright, so I have this question to solve. The problem is, how do I solve this? Okay, now let's try to factor the denominator. Can we factor it? If you try to factorize this, I don't think it will be possible. So what we can do is just separate it. Okay, so this integral is going to be integral of 8 over x squared plus x minus 1. Okay, dx, then minus, okay, because there's a minus between the 8 over whatever. You let me remove the minus, the dx there. Okay, and come and write it here. I want to write it somewhere that you understand how we got that fraction. Okay, so this integral is equal to integral of now 8 over x squared plus x minus 1, or minus x over x squared plus x minus 1. Okay, now all of this dx. This is true because they have the same denominator. If I subtract them, I'll get back this. Okay, so if you are subtracting two fractions of the same denominator, we said you take one denominator and subtract the power, the numerators. Okay, and now this will give us integral of 8 over x squared plus x minus 1 dx minus integral of x over x squared plus x minus 1 dx. Now this is what how. Okay, so how do I integrate this? Wow, if we can factorize the denominator, then we can use substitution, simple substitution rule, and then go. But try factorizing it yourself. If you try doing that, you can't. Okay, you can't factorize. So what you do is, let's try to complete the squares of the quadratic denominator. Okay, so if I have x squared plus x minus 1, then this is the same as saying x squared, okay, plus x plus, then I'll have the coefficient of the x. Coefficient of x is what? 1. So if I have it is 1 over 2, then I'll square it, add it to the x component, then minus 1, then I'll subtract it from the constant component. Okay, why are you doing this? Okay, why are you doing this? Is you want to have something that we call quadratic trinomials. Okay, if you are not fan of quadratic trinomial, you can go and read on that. Okay, so that guarantees us for us to do some simple factorization on this quadratic form. Okay, now from the quadratic trinomial, this is the same as x squared, sorry, let me show you why I wanted to show you, but we'll do that in another video. Okay, so from quadratic trinomial, from this side, only this side, the factorization will give us x. I'm coming. Factorization will give us something like s plus half on 2, 1 over 2, sorry, squared, then minus 1 over, it's 1 rather, okay, there's no over, so minus 1 minus 1 over 4, okay. So now I want to erase the top one, or let me write it here. So s squared plus x minus 1 is actually equal to x plus half then squared minus 5 over 4, okay. So this is what we've gotten, alright, for the denominator, okay. So it means the denominator is the same for this side and this side, so it will work for both, okay. Now let's clean them and wrap up fast and solve it, okay. So now our integral has turned to integral of 8 minus x all over x plus half all squared, okay, minus 5 on 4, okay, dx, okay. So now how do you go about it? Okay, how are you going to integrate this? Like I said, you can separate it, okay, but before you separate, let's look at something, okay. Let's look at one interesting thing. We can, before we do the separation, we can let our u be equal to x plus half. Then it means that du dx is equal to 1. It means the u will be equal to what? Dx. Okay, we've done this in our previous video, so you can watch that integration by substitution, okay. Alright, so with this, let's look at it. Du is equal to dx, okay. Now I can quickly set my du in and say 8 minus x over u squared, okay, u is the same as x plus half, minus 5 over 4 the u, okay, ds is equal to du, but there's still an x here. But look, from what we said u is equal to x plus half. It means that our x, making x the subject here, is what? U minus half. So I can quickly come here and put it in, and this will give me integral of 8 minus what? X is u minus half, okay, all over u squared minus 5 over 4 du, okay. So let's simplify this, the denominator, okay. Alright, so doing this we'll get something like a integral of 8 minus u, okay, plus half all over u squared minus 5 over 4 du. Then this is equal to 8 plus half, okay, so 8 plus half is just 8.5, okay. I don't know how you can, it's just 17 over 2, okay. So integral of 17 over 2 minus u over u squared minus 5 over 4 du, okay. So now we can separate them and solve like I was doing, okay. So everything is now simply like putting what's u, okay. So let's try to separate them. So with this, we said you can separate this and write something like integral of 17 over 2 into u squared minus 5 over 4, okay, du. For the first part, then minus u integral of u over u squared minus 5 on 4 du. So this is how it becomes, okay. The 17 over 2 over u squared minus 5 over 4 will give you this, okay, and it separated minus u over that. Okay, we did this just beginning of solving this problem, so I hope you understand how we separated it. So now I have two separate integrals to solve, okay. You can do a lot about it, but I'm trying to solve the second one. I will solve the second one first. So well, that is the easiest one you can do, okay. So let's solve the second one first. So with the second integral, I have integral of u over u squared minus 5 over 4 du, okay. So this one you can let another function represent. Let's say k be equal to u squared minus 5 on 4, okay. Then the k du is actually equal to 2u, so that our du, this implies that our du will also be equal to what? K over 2u, so that this u will come and eliminate the u at the numerator of this, okay. Hope you understand it. So I'm just coming to take some things out and put them here, okay. So I'm just adding them. You know, we said k is what? The denominator, okay, and the du is what? Let's erase the du and put it there. Du is what? Dk over 2u, okay, so that this u will take this u out. Now we are left with what? So if that is the case, then we'll get something like this: integral of 1 over k times dk over 2, and dk over 2 is the same as half dk, so this will give you half integral of 1 over k dk, which is equal to half ln of k, okay. But k is what? K is, so you can have ln of u squared minus 5 over 4, okay. But we know that, and this will give us, let's say, ln of square root of from logarithm, okay. Let me maintain it like that, okay, but if you want you can change it to that part, okay. So here, once we are done putting k in, let's erase some part and put our u back. U is also s plus half, okay. So let's try to erase some parts. This is the same as, in terms of x, is the same as half ln of x plus half squared minus 5 over 4, okay. There is a second part of our integral. Mind you, we had an integral of something like this: 17 over 2 into 5, sorry, when it was in terms of u, okay. So this is what we had: 2u squared minus 5 over 4 dx, sorry, du minus integral of u over u squared minus 5 over 4 du, okay. And this part, this second part, this side, has this solution, okay. So let's keep that at some point and come and do this one. After that, we subtracted this one from this, okay. So we subtract this one from this one. Alright, so let's clean it and write this answer somewhere. Alright, so this answer I'll put it somewhere for you. Okay. Okay, so this is the other part, okay, the hardest part. So let's look at this. This integral is the same as 17 over 2 out integral of 1 over u squared minus 5 on 4 du. Okay, so the only part you should concentrate at is the integral part. Okay, so now you go and consult these people. If you remember, we said something like if you have u squared plus or minus a squared, that is what we started with. Okay, I said if you have, let's say, s squared plus or minus a squared, then what you should consult is this side. I'm writing it here. 1 plus tan squared theta is equal to sec squared theta. Okay, so we are going to use this to solve this question. Okay, because other than that we can't do this. Okay, now we said that before you do that, you should make sure that your denominator, this side, is in terms of some variable plus or minus 1. Okay, so we have to do and check those things as well. So let's see. Alright, so we said 1 plus tan squared theta is equal to sec squared theta. Okay, so keep this. And now with that, you have to factor this one, this side. Factorize it in such a way that we get u squared plus or minus 1. Okay, by this time we are dealing with minus, so it becomes u squared minus 1. But the only way we can do that is let's factor in, just try to factor 5 over 4 out. Okay, then we divide u squared by 5 over 4. So u squared, this one, u squared over 5 over 4 will actually give us 4u squared over 5. Okay, I hope I'm correct. Okay, so I'm just coming to quote it inside. Okay, just one question. Look at how we are struggling, but I believe that if so just one question, but it's very long, so integration is really tedious. That is why I always say try to understand from the basics. Okay, so this becomes 5 over 4 into 4 u squared over 5, okay, minus 1. But it doesn't look good because this doesn't look like this one. Okay, it doesn't look like that. Okay, so what we can do is that, okay, but the reason why we are quoting this is that we can actually write tan squared theta to be equal to sec squared theta minus 1. Okay, so we want to get something square minus 1 in this. Okay, alright, so how do you go about it? Now if you consider 4, clearly, it's as if 4 is the square root of 2. Okay, and 5 is also the square, 4 is the square of 2 rather. Okay, 4 is the square of 2, and 5 is also the square root of 5. Alright, so let's see. So this whole thing then becomes 5 on 4, then into brackets 2u over square root of 5, okay, all squared. I hope this is cool because if I square this, I'll get back 4 over 5, 4u squared over 5, okay, minus 1. Now this looks like tan squared theta equals sec squared theta minus 1. Okay, so now this whole thing is equal to 1 over 5 over 4 will give you 4 over 5. Okay, so you get 17 over 2. Then I pull the 4 over 5 out. Okay, then integral of 1 over 2u over root 5 squared minus 1. Okay, this is cool, right? So this whole du, there is a du attached to it. I hope you remember. So this whole thing is equal to 2 goes here 1, then 2. It's 2 times 17, and it's what, 34. Okay, so 34 over 5, the integral of 1 over 2u over square root of 5 squared minus 1. Okay, du. So now we said we'll use tan theta, or tan squared theta is actually equal to sec squared theta minus 1. Okay, so we use this idea since we have something square minus 1 in the denominator. We'll use this idea. Okay, so now let's come and clean everything and write our new integral again. Alright, so this is what we have, and we said we are going to use tan squared theta is equal to sec squared theta minus 1. Okay, so we let 2u over square root of 5 be equal to sec theta. Okay, then you know that u will be equal to what? Square root of 5 over 2 sec theta. Okay, then du will actually, du the theta will be something, so du will be equal to just square root of 5 over 2 sec theta tan theta. Okay, I hope you can see. Let me write it well. So therefore our du will be equal to square root of 5 over 2 sec theta tan theta. Okay, the theta. Alright, so like I said, if you don't know how to do trigonometric differentiation, I have a video on it. Just kindly check it up and see. Okay, alright, if that is the case, then we just put everything in. You get 34 over 5 integral of 1 over 2u over square root of 5 is sec theta. Then the square will give you what? Sec squared theta minus 1. Then du is what? Du is giving us square root of 5 on 2, then times sec theta tan theta d theta. Okay, so let me clean some parts. The theta like that. So I've put everything inside. Okay, so this will give us, I hope you remember the du. Okay, so I'm now coming to clean it. See how tedious it is. So this is equal to 34 over 5 the integral of 1 over tan squared theta times square root of 5 on 2 dot sec theta tan theta d theta. Okay, so now one of the tan theta will cancel this how do I call it, tan squared theta. Okay, so we'll get something like 34 over 5. I'm pushing the square root of 5 over 2 out. I'll get square root of 5 over 2. Then the integral of this tan theta will take one of these. Okay, so we get sec theta over tan squared theta, sorry, tan theta. Okay, because one theta will go, and that becomes that. Okay, now let's try to clean everything and write everything afresh. Okay, so this 2 goes into this 17 times. Okay, so you get 17 root of 5 over 5, then integral of sec theta over tan theta, okay, d theta. Alright, so now you know that sec theta is the same as 1 over cos theta, right? And tan theta is 1 over tan theta is what? Cot theta, which is cos theta over that. Okay, so this whole thing will give me 17 root 5 on 5. Integral of sec theta is what? 1 over cos theta, and 1 over tan theta is cot, which is cos theta over sin theta. Okay, d theta. Okay, so now this will take this out, and we'll get 17 square root of 5 over 5 integral of 1 over sin theta. Okay, which is the same as saying 17 square root of 5 over 5 integral of cosec theta d theta. Okay, so now how do you integrate cosec theta? Okay, alright, let's see. So what I'll do is that I won't write the 17 root 5 over 5 again because it's getting tedious. Now let's keep in mind that after everything we can multiply by 17 root 5 over 5. So our main task is to integrate this. Alright, to integrate this, we'll try to do something we call creating and destroying. Okay, so we have this, then multiply by, so multiply this by cosec theta plus cot theta over cosec theta plus cot theta or the theta. Okay, so with this we'll get something like this: integral of cosec square theta plus cosec theta cot theta all over cosec theta plus cot theta d theta. Okay, so I'm now coming to erase it again. Now we have cosec square the 17 square root of 5 over 5 is still multiplying it, so we have cosec square theta plus cosec theta cot theta over cosec theta plus cot theta. Now we'll let u, or let's, if you use u here, so let's make k. Okay, let's use k. Okay, k be equal to cosec theta plus cot theta. Okay, now the k, the theta, will actually give us, integrate cosec theta, we get minus cosec theta, and come in, let me erase it. We get minus cosec theta cot theta, then when you differentiate cot theta, you get minus cosec squared theta. Okay, now it means that the theta will actually be equal to, I'm making the theta the subject. Okay, so when I cross multiply, let me do it. Okay, let me do it manually because I don't want a situation whereby this one will confuse you. Okay, So we get decay is equal to, cross multiply, we get negative out cosec theta cot theta plus cosec square theta, then the theta. Okay, so I'll get my d theta to be equal to decay over minus into cosec theta cot theta plus cosec square theta. Okay, then I just go back and put everything in. Okay, so k is equal to cosec theta plus cot theta. So now this is where we'll clean. Okay, we need to just clean this side and leave the k and the theta because we already know them. Okay, so everything, mind you, I said after the integral we'll multiply our 17 square root of 5 over 5 by 8. Okay, so everything will then be equal to, this implies that we'll get something like integral of cosec square theta plus cosec theta cot theta all over u. These are u, right? So let's see, then times decay over negative of the expression. What this expression, I can interchange it, so it's like cosec square theta plus cosec theta cot theta. Okay, alright, I hope you can see that it's the same expression that is at the top here. Okay, so I can cancel this and that, and there is a negative here, so we just put it in mind. Okay, alright, now let's continue. So this will give us integral of 1 over, sorry, it's a k here, shouldn't be a u. Okay, it's a k as 1 over k dot decay over negative 1. Okay, so just negative integral of 1 over k decay, which will give us what, negative ln of k. Okay, and so we are done with the integral. Now what is our k? Alright, so we are coming to write back our k and things. Okay, I hope you understand how you got the integral. Okay, it's very tedious. It's a tedious work. I said that after the final answer we have 17 root 5 over 5 times the final answer, which is negative what, ln of k. So let me just bring a negative in front of the 17. Okay, since there is a negative here, I'm coming to multiply the 17 root 5 over 5 to it. So when you multiply negative, you get negative 17 root 5 over 5. Okay, then ln of k, and k is what, cosec theta plus cot theta. Okay, oh wow, so this is the answer in terms of theta. Okay, but let's find u in terms of theta. Theta shouldn't be in our answer because our answer is supposed to contain x. Okay, so let's convert everything back. Okay, so we have negative 17 root 5 over 5, then ln of, now coming here we said u was equal to what, square root of 5 over 2 sec theta, right? So it means that if I want to find my theta in terms of u, now coming here, you know that 2u over square root of 5 is sec theta, so it means that our theta is actually equal to sec inverse, okay, of 2u over root 5. Okay, so now it becomes cosec of sec inverse of what? 2u over root 5, okay, plus cot of sec inverse of 2u over root 5, okay, and you have to convert our u's back to s, okay. Alright, so we know that u is equal to x plus half from this side, okay, from this side u is equal to x plus, so we have negative 17 root 5 over 5, then ln of cosec of sec inverse of 2, u is what? X plus half all over square root of 5, and plus cot of the sec inverse of 2 into x plus half over square root of 5, okay. I hope you can see this, okay. So this is the solution to the second part of the integral. So we said the actual final answer, of this whole integral is this one, the first one, minus the whole of this, okay. So it's half ln of x plus half over 2 squared minus 5 on 4, okay, then minus, and there's a minus sign here, so here there's a minus sign in front of it, should be the whole of this side minus the top one, okay, but there is a minus sign in front of the top one, so we don't consider it, okay. So what you do is, and it becomes minus minus, then it becomes plus, so it becomes plus, then we start, what is that? It's 17 root 5 over 5 ln of, then you put your things in, okay. So it's cosec of sec inverse of what we've done here, okay. So let me write it at the bottom here, so at the down here, so that you see it clearly. So we have the whole of this plus 17 root 5 over 5 ln of cosec of sec inverse of the expression 2 into x plus half all over square root of 5, okay. Then there's another bracket here, oh, there was another bracket here, I didn't bring it, then plus cot of the expression sec inverse of the expression 2 into x plus half over square root of 5, then you put your number of brackets, okay, then you bring your absolute bar. So this is the final answer. Oh sorry, all plus c, okay. So this should be the final answer. Alright, it's just one question, but it takes almost an hour to solve it. Thank you, and don't forget to subscribe to my channel, okay.